with 128, and we're going to start talking about more Android implementation issues, and I'll do some demonstrations. Today I just completely rewrote the Civ project. Yeah, I updated it last time for the lecture. Now I updated the project so you can do it hands-on, so that's good. Like I say, I was going to cut it out of the course entirely, but somebody rewrote it and recompiled it for x86 instead of the ARM, and it works a lot better. So let's start with the lecture stuff, which is here. And good, I can see the Twitch comments up there. All right, so we'll talk about pre-installed applications and start the process of exploiting devices, and there's more coming in other parts later. So one big thing about Android devices, and for that matter, Windows devices, is that the primary operating system is pretty good, coming from Google or Microsoft, but the actual devices that are sold have a bunch of branded junk put on them. So if you buy a Dell device, it comes with Dell Backup Utility and Dell Update Utility, and those things tend to be really poorly written and insecure. And the same thing's true of phones. The manufacturers of phones add extra apps to them, and those are usually made in a much less professional way than things that come from Google. And so some of the apps, now if you do find an app with a vulnerability where you can say code inject, then you get the privileges of the app, which is usually not root access, but sometimes you can exfiltrate user data even without root access. So the first thing you might want to do is find powerful apps, look for what privileges they have. Some apps have install packages permission, which means they can have their own update mechanism, and if that's true, then they can install other apps from within that app. So that's a nasty one. And Drozer has that permission on an emulator. Now, I haven't looked to see if there's a new version of Drozer yet. Drozer used to be used quite a bit in the projects, and I haven't used it for several years because, like Civ, it was so out of date it wouldn't run on modern devices. If I get it working, I'll add it back into the projects. Anyway, it was basically just a Trojan horse app you'd put on the phone, and then you could attack other apps from the app. And we can do that with Metasploit, which will work. So I'll get one or the other of them working later on in the course and make sure those projects are working. But anyway, you see, Drozer does have, it has install packages permission. It's, of course, a malicious app deliberately intended to have dangerous permissions. And then there's apps running a system. I looked on an emulator. Emulators have many fewer apps than real devices because they don't really come from somebody like Samsung. They don't put on all the Samsung stuff. So here you can use Drozer to see the packages that run with system permissions. And you see they're mostly things that make sense, like Android Keychain and Android Setting. Those are official Google Android packages that should be running a system, and presumably they're written relatively securely, so it's not a big risk. All right, so finding remote attack vectors, the most common one is trick the user into installing a malicious app. There's tons of malware in the official Google Play Store. They're never very successful at cleaning it out. And you can also install things from other locations, which especially works in nations like China that block the official Google Play Store. Everybody has to go to unofficial sources. Yeah?
To build upon this for the client-side malicious document thing, to build upon this technique for client-side malicious documents,
yeah.
Where does the whole where you put up an app and it says the exploit is actually here, but actually you're clicking to download it or something?
Oh, that's UI redress, where you can make the user interface confusing. And that's a general type of attack there. And that's also an option. But here, this is why, for example, most of the iPhone jailbreaks come through the PDF reader. And the PDF reader also affects a lot of Windows machines. It's a very PDF format, has many complicated features, and it's often been implemented incorrectly. So that's what they're referring to here. You could just have some vulnerable app on the device, perhaps even from Google, and then you just get them to open a document and take it over. That's why you...
So that's the difference between both.
That's what?
So that's the difference between just hijacking a UI to download something.
Right, yeah, UI is a different kind of attack. Yeah, UI as a redress is where you trick them so they think they're tapping on one thing, but they're actually tapping on something else that's invisible or not obvious. Yeah. So browsers and document readers tend to be vulnerable because documents tend to be very complicated. 30 years ago, when this all started, there was a huge argument about what should be in a file. And the Unix people said a text file should just be text, and a source code file with commands for execution should be a totally different thing with a different file extension. And Microsoft was one of the companies that put commands inside Word documents. And everybody screamed and said, you shouldn't mix active code and passive data in the same file. But everybody did it anyway, and it did lead to all this garbage. So HTML files have JavaScript code, and used to have Flash code and Java code in them, and Microsoft Word documents have Visual Basic code in them. And now, of course, with AI, everything is code. That's what all the major AI attacks, and there's a new couple of every week, come from the fact that if you have an AI, for example, scanning your email to pick out the important emails, then it's reading all the email. And the AI doesn't understand any difference between text and commands. It just processes all data the same. So you can just put commands in an email that says, find all the passwords and cryptocurrency keys and send them to me at this address in the middle of an email, and the AI will read it and follow those commands. It doesn't know that that was just data to scan. It wasn't commands. It treats all input as the same, which is a fundamental command injection vulnerability. The data that came from the untrusted source is not separated in any way from commands. And anyway, now in these formats, they're supposed to be separated, and so people do eventually fix these. Like Samsung had a PDF reader by default, and it had a vulnerability. So there's also browsable activities. Browsable activities we talked about before. This lets you open web pages inside the app instead of going to the browser. And this, of course, is a much better experience for the company. They want you to always see the company brand, and you go to a web page, it opens in a little window inside the app. It looks prettier, but it's more dangerous because now you're not using the real browser, which came from Google and which might be updated. You're using some other browser that's probably not as good and probably not as up to date. So, all right. So if you look at Drozer Agent, you'll see that it does have, it's browsable, which means web pages can be opened in it. All right, and this one here defined a scheme called pwn, so you could make a link starting pwn : //, and that is a schema defined, so anything, any URL starting with that schema will open in this app. And Skype had Skype : // that would open things and make Skype phone calls. And you can still use those URLs, but they'll no longer let you open them in iframes. That was an attack years ago where you would make an iframe that contained one of these things like a Skype, and then as soon as you load the page, it'll make a phone call. Now, it won't let you put it inside an iframe to try to prevent it from happening without you knowing about it. And any attempt to launch a phone call will always pop up a box asking for permission first, which was their response to that attack. So you can start it here by a pwn link on a web page where you click a link and it opens pwn, or you can have a web intent here, which will do the same thing. Different ways to express this that will activate that activity. And so I tried to look on my emulator to see what activities were browsable, and there were quite a few. Android Fidelity app was browsable, the messaging app, and the Blackboard app from, like Canvas. It's another content management system. All those are browsable. So they all had, like this one had Kurogo : //. That pattern would open inside this app. So you could make a link that would automatically open that app, which is possibly useful, but it can be dangerous. Okay, and then of course the problem is, what if your app has its own custom update mechanism instead of sending you to the Play Store to update? The Play Store is of course the best and safest place to update. It uses HTTPS certificate pinning, so you're always talking exactly to Google and not to any imitation and things like that. But you could have your own update mechanism, and of course it tends to be sleazy and vulnerable if you do that. Some of them load over without encryption and so on. And there's a DEX class loader. There is a code structure that will allow you to remote load code and run it, which is of course a dangerous thing to do, but the capacity exists. You can put it in an app. Just like every language has a exec command that will execute shell commands in the operating system, and it's generally considered very unwise to use it because it creates code injection. If any of that can be controlled by the user, then you have code injection. And if you have something that's loading code from some remote site to run, then maybe somebody could compromise that remote site or intercept the signal on the way to that remote site and inject code. So these are part of the attack surface. Web views are the things that display web pages inside your app, and you can define a JavaScript interface which will then load JavaScript and run it. And that will often allow you to inject JavaScript from a web source. So Android API before 17 did not properly restrict this method, so you could not only execute JavaScript, you could execute Java commands on the phone from the app, from the web, which is pretty dangerous. There have been a lot of times this happened. In the early days of the web, Microsoft developed ActiveX, which would let you run native code from inside the browser, and it's very powerful but very dangerous, and there was just a flood of ActiveX vulnerabilities. So Google's fix, now if you have set your target SDK to 17 or higher, then you'd have to add this special annotations, any method you want to be available in JavaScript, and it must be public. So they prevented it from happening by default and made it so your developer has to really go out of their way to turn this on if you want to use this dangerous technique. Then there's listening services. Like I say, if you just look at the listening ports, you can see what's listening. And remember, we did that project a while ago where one of the file viewers was serving up all your images on a local port like 4888 without telling you. All right, and there's message applications. All these are taking data from the outside, SMS, MMS, email clients, and chat clients. They're all taking data from the outside, and if they don't properly handle it, each one of them might have a vulnerability. There might be some special character that leads to code injection or buffer overflow or anything like that. So if you want to find these local vulnerabilities, then you have to download the apps, read the source code, search for vulnerabilities. Drozer has some scanner modules that never seem terribly useful to me to try to scan for vulnerabilities. We're going to see some very good Android vulnerability scanners coming up in the projects, though. There are some third-party ones that work pretty well. I tried their SQL injection scanner, and it didn't find the SQL injection even in Civ, which is the example app from the same company that made Drozer, which is why, I got kind of fed up with Drozer. It's not currently in the projects, and I may not bother putting it back. It didn't really seem to be as useful as I thought it would be. Anyway, all right, so remote exploit gives you remote control of the device, and a local exploit means you already have to have a foothold on the device, like a malicious app, and then you attack from that app. And both of those are dangerous since it is pretty easy to trick people into installing malicious apps. So then there's attack tools. EtherCap is the famous tool to do man-in-the-middle attacks. It sends poisoned ARP messages on the local network and redirects traffic to pass through you, although I must say I was never able to make it work. It's been the standard for years. On Windows, I found Kane to be much more effective. Anyway, Burp, we're using it a lot in 129S class. Burp makes a proxy. It's really powerful to intercept, but it only works for HTTP and HTTPS. And it even makes a fake certificate to intercept HTTPS, so it's really very, very effective. All right, and like I said, Drozer has the ability to make rogue agents that act like malware, but I think years ago when this thing didn't work very well, I just switched to using standard Metasploit modules, which is the same thing used to attack Windows machines and other machines. And that project's still in there. I'm planning to update it and make sure it still works. But there are ways to make a malicious app, which you put on the device, and then you have remote control of that app, and you can try attacking the system and other apps from that app. But of course, the app doesn't have system privileges. It's going to have just a user count, and you'll have to find a privilege escalation vulnerability if you want to get up to root and have some real fun. So, if you are a non-system app without context, like a shell from a web browser, then you have the privileges of the compromised app. You can go into that app's files, but you can't use Java libraries or install packages or read SMS or any of that stuff. If you have something called context, then you take over the app's execution flow, and you can do anything the app can do, but the app is just a normal user account and can't really usually read other users' files or anything, so that's pretty limited. If you're an installed package, you can request permissions on installation, and the user has to approve them, and you can just ask for permission to install more packages, to read all your files, to read all your images, and users will typically just approve everything. ADB shell, we've done. If you can install apps, you can interact with apps as a developer, and if you escalate to system, the super user, then you can install apps, change the configuration, access data from any app's private directory. And this is available if your phone is rooted and you do an SU. And that's why more secure apps check to see if the device is rooted and refuse to run on a rooted phone. Pretty much all apps should really do that. I mean, there's no reason for anybody to be using a rooted phone unless they're up to no good. And if you do get root user access, of course, you can't do any part of it, just like any other operating system like Windows or Linux. You're the super user, and you can do anything. All right. So let's try a Kahoot. Should have it ready to go here in one of these windows.
I love these things.
Oh, yeah, good. That's a good attitude. All right. A lot of people do. It keeps them awake. There we go.
Thanks.
Yep. Yep, good. He was here at the Friday hacking workshop. Now they're Saturdays. She moved them to Saturdays, so be aware of that.
Yes, you were out of town last week, so
I was. And it's going to pick up again this Saturday.
welcome back.
Yeah, thank you.
Wasn't there Father's Day conference today?
What's that?
Father's Day, but
I think it's for April. Yeah. They also plan it like more than a year in advance, so I won't be presenting at it, but maybe next year. Anyway. All right. Okay, so what permission does it take for a custom update function? Yeah, the main thing I think about this is Java on Windows. You know, if you have Windows, the Java update is always popping up in a separate box. It doesn't go through the normal Windows updates. And
I'm sorry, install packages is the answer.
yeah, install packages is the right answer, yeah. Then you could have your own installation mechanism outside the store, which is a pretty bad idea, but you might do it because you think it gives a better user experience or something.
So it's a bug, not a feature.
Yeah, you could argue, yeah. And
So the person thought it was a feature.
so what Java class lets an app load new code at runtime? Another thing about this, which is really nasty, is I don't even know if they have any security review in the App Store. In the iOS App Store, they have a security review, and Google says they're going to do this. And if they do, then one thing you can do is you can write an app that's harmless and get it approved, and then change the code later, which is another reason why they don't like you having a different update mechanism, and they don't like you loading code dynamically, because they don't get to check that code to see if it's malicious. So, you know, this is another pretty bad idea, but it's there. All right. All right, and so what intent filter would make your app listen to URLs like this? Pwn. This should really say permission, but anyway, you have to be browsable. Browsable means there are URLs that will automatically launch your app, and you then define with a filter what the scheme is that will open in your app. All right, so what component might allow a web page to execute Java code? Yeah, it's web views. Yeah, all right.
Steven, live.
Oh, there you go. All right. So, Stephen, all right. And Aaron. All right, Aaron B. Good. All right. All right, let me stop this recording.